So what you're looking at here, this is Lytro cinema. This is the first generation of something that we do believe is a historic moment for cinema. This is 10 years in the works. Lytro has been working towards a vision, and we believe that this is that next step towards achieving that vision. And we are really excited to have such strong industry support. I couldn't have in my wildest dreams imagined that we would have standing room only here. And this is actually beyond standing room only. So I'm going to actually, throughout this presentation, show you the visual effects. I'm going to break it down. I'm going to show you the software. I'm also going to do a highlight reel for what the actual technology comes with, how it works. And after the session, I do encourage everybody, well, maybe not everybody, but as many people as can fit in front of the little line here, please do take a very close look, and you'll be able to actually see the imaging sensor that goes into this, which is really just an extraordinary piece of technology. Over there on the left side, what you see are the points in space. They're just arbitrary, forget about the colors, just to help you see how we're ray tracing into a light field system. The way that that camera right there works is you have a main lens, obviously not just one single piece of glass, there's a lot of glass in this thing, and then you have at the focus plane of that camera a micro lens array. And that micro lens array consists of millions of lenses in this camera. So obviously this is not to scale, otherwise we wouldn't be able to fit everybody in this room, because that would be a very big camera. And behind each of these micro lenses is a bucket of pixels. Each of these pixels represents effectively one sub-aperture image. And what a sub-aperture image means is it's a full resolution perspective from the entrance pupil of the lens. So think of a camera array. In this example here, you have 6 pixels behind each of those micro lenses. That would give you effectively 6 by 6 or 36 camera perspectives crammed into one lens. So that's the easiest way to correlate between a light field array and planoptic capture, as you're seeing here with a micro lens array. If you look right in here, you can actually see the many millions of lenses inside of the camera. So we've left this open. We've left, basically pulled the lens aside so you can actually see inside of the camera. Behind that is the sensor. The sensor is the highest resolution video sensor ever designed. And if you know of one that's higher resolution, please let me know. It'll be a lot easier for me to build this. Okay. From that, it is 755 raw megapixels of light ray capture. And that is able to be captured and streamed at 300 frames per second. That is something that we've worked very hard on in order to make sure that we can achieve everything and anything in between to meet, if not exceed, industry standard requirements. You'll also note that this is a thermally cooled system. We make sure that in all environments that you are actually able to not only maintain the signal integrity, but also maintain your dynamic range and your signal-to-noise ratios. I'll mention a bit more about that when I do the actual live demonstrations for you, where you're able to see just how clean the image quality can be because you have hundreds of input samples for every one output sample. What you're seeing here is the actual live display. This is giving you actual active samples into the real world that is showing you. Is anybody in front of the camera here? People jump around? Anybody jump? Nobody's jumping? Okay, thanks, Goalie. All right, so if you come over to the front here, no payment for performance here, you'll actually see in the front, this is the active scanning system. This is completely integrated and tied into the light field system. You'll also note there are 2 full optical paths. The path on the top is the light field optical system. The path on the bottom is the creative preview lens. When we talk about the preview lens is what you actually use on set. And thank you to our good friends over at Red Rock for our focus and depth of field controllers. This is how you're able to, live on set, actually dial in your creative decision. And this is very important. One of the things that we believe very strongly in is that nothing fundamentally changes on set that you are traditionally used to doing. So you have the ability to actually focus, you have the ability to use a depth of field controller, you have the ability to control all of the parameters, including your frame rate and your shutter angle and everything and anything in between. So what you actually see on this live monitor are, in fact, those decisions. But that doesn't mean you're actually saving just that data. You have the entirety of the light field that is actually being captured. So with those decisions, it is actually saved as a real-time QuickTime file, or ProRes or MXF, depending on your production needs. That can immediately go to editorial or be immediately reviewed, so you can check your composition, you can check your framing, you can check the acting and performance. So we wanted to make sure that there is no latency, there is no delay, that while you're on set, you have full control over the captured content, and that fundamentally nothing has changed outside of the fact that now you have all of the rich metadata from capture. So there's a lot more features here, and I'm not doing it complete justice, but the engineering team at Lytro is truly some of the most brilliant talent I've ever had the opportunity to work with. And to be able to bring this into the industry and show it today is nothing short of a heroic effort. One of the main attributes of the light field is the fact that you can re-render it in any number of ways. Some of the things that you can do is arbitrarily change your frame rate. You can change your shutter angles. You can obviously change your focus, your depth of field. You can change your stereo parallax, and this is all something that is fully controllable after you capture the content. It's something you can do in post-production, or alternatively, you can lock in the decisions that you made on set. And that is yet again something that we believe very strongly in to protect the creative intent of the content. We also have the ability to physically lock all of the creative decisions that have been made. That will be part of the commercial release of the software. So once the decision is made at whatever time is appropriate for production, be it in DI, be it during editorial, or during a dailies process, those decisions can in fact be controlled by the production. So we just want to be very sensitive to the fact that there's a lot of things that can happen, a lot of conversations that can occur about who has final control over the actual content itself. And then finally, we consider the light field the ultimate mastering format. We're able to take all of the content, your visual effects, your matte paintings, your 2D elements, your 3D elements, we can convert them with our tools into a 4D light field, and then you can master the one image, and even after you post the film, even after you deliver the film, you're able then to re-render out anything that may be required in the future, including potentially light field or holographic display.